Hello and welcome to this tutorial. I'm solving question number 11 of paper 2 to May June exam series of 2018 paper, and this question is related to the radioactivity and the half-life. Okay, the question says a smoke detector contains a small radioactive source of americium 241. A smoke detector is a device which is used for fire alarms, and in one type of smoke detector we do have a radioactive source of americium 241. The source emits alpha particles. The first part says, in the space below, draw a diagram of an apparatus that can be used to show that the source emits alpha particles. So not only the source is radioactive, but it is emitting alpha particles, and we have to make a diagram and show that how could we detect that some source is emitting alpha particles. So for example, we have this source, and we want to detect whether it is emitting an alpha particle or not. So we could place a detector in front of this source, and this detector could be the GM tube, the most convenient one, and again this GM tube would be connected to a rate meter on the other end, which would be showing us how much count rate it is detecting. So this is the rate meter which shows radiations received by the GM tube. So when we place any absorber like a sheet of paper in between the source and the GM tube, the count rate on the rate meter decreases, and it decreases to a value of background radiation which were noted before. So it shows that all the radiations coming from this source are absorbed by this paper, and we know that paper can absorb alpha particles. So the decrease in the reading of the rate meter shows that whichever radiations were being detected by the GM tube, they were actually alpha particles, because when we have placed an absorber in the way of the source, the rate meter is showing the decrease in the count of radiation. In the next part, the question says describe how this apparatus is used. We could count the radiation value when the source is placed without paper in between the source and the detector, which is the GM tube in this case. Then we could again take the value of count by placing a paper in between. So since alpha particles are being emitted, they would be stopped by the paper, and the count rate should decrease. There could be another way of doing the same thing, that when we have placed the source of americium 241, it would be emitting alpha particles. So if we apply an electric field around it, one is negative plate and the other one is the positive plate, then this should show some deflection towards the negative one. So by deflecting the emitted particles, we could also conclude that the source is emitting alpha particles. So one of these methods could be used to explain this answer. In the next part, the question says explain how the results of the test show that source emits alpha particles. I'm writing when a paper is placed the count rate decreases to the value of background radiation. So it means no active radiation from the source is being detected by the GM tube of the detector. And we know that only alpha particles are stopped by a paper. So if there would have been beta particles or gamma particles being emitted by the source, they would have gone through this paper and they would have been detected by this GM tube and the rate meter. So since the value is dropping to the value of background radiation, which shows that only alpha particles are being emitted here. The next part says the smoke detector works because alpha particles from the source ionize the air. Compare the relative ionization effect and penetrating powers of alpha particles, beta particles, and the gamma rays. The ionization effect of a radiation depends upon its charge. So alpha particles, they possess a positive 2 charge. Their ionization effect is largest. Beta particles have a half of the charge, -1, so their ionizing effect is lesser. And gamma rays, they are neutral, so they have the least ionizing effect. So I'm writing alpha, the effect of alpha is larger than the effect of beta, and the least effect is shown by the gamma. The second thing is penetration effect. It depends on the speed of traveling of the ray or the particle, and since the gamma rays have the highest energy, so their penetration effect is larger. Second one is beta, and the least penetration effect is shown by the alpha particle. Okay, in the next part the question says americium-241 has a half-life of 430 years. So this is the half-life of this radioactive substance. Radium-224 is another element that emits alpha particles. It has a half-life of 3.6 days only. Explain why americium-241 is more suitable as the radioactive substance in a smoke detector than radium-224. So since americium has a larger half-life, so it works for longer period of time. If we use a substance which has a shorter half-life, it would be needed to be replaced repeatedly or frequently. So americium is a better choice because it works for a longer period of time. The next part says a smoke detector contains 8.0 10 raised to 11 atoms of americium-241. Calculate the time taken. We have to find the time for the number of atoms of americium-241 to fall to 1.0 10 raised to 11. So it means the starting number is 8.0 10 raised to 11, and we would be dividing it by some half-lives, which could be generally represented as 2 raised to n, and the count or the number of atoms would decrease to 1.0 10 raised to 11. Now to find out the number of half-lives which is being represented by this small n, I would move 1.0 into 10 raised to 11 to left side, and I would be moving 2 raised to n to the right side. And when we divide it, we get the value of 8 here equal to 2 raised to n, which means 2 raised to n is equal to 2 cube. I'm converting 8 into a base of 2. Now if we equate the exponents or the powers on both sides, we get the value of n equal to 3, which shows that number of half-lives here would be equal to 3. Now in order to find the time, we just need to multiply this number of half-lives with the half-lives value. So 3 would be multiplied by the half-life of this was given to be 430 years. So I'm multiplying it by 430 and the answer is 1290 years, which would be converted to two significant figures and it would be written as 1300 years, the answer for this part. The next part says when used correctly, the radioactive source in the smoke detector is less harmful than background radiation. State one harmful effect of background radiation. So it could damage our cells. This could be one harmful effect of the background radiation. It could also cause cancer or it could also cause mutations. The second part says a radioactive source is picked up using a long handled tool. So this is one safety precaution that is always taken, that radioactive source is picked up using a long handled tool. Explain why this is safer than using a short handled tool. So the first thing is if we are using a long handled tool, the distance between the source and the body increases, which is obviously more safe. So as a result, there are less chances of radiations reaching the body. So that is why the long handled tool is much better than using a short handled tool. So with this part, the question ends here.
We try to explain complex concepts in simple language and with effective examples. If you liked the video and the way we explain the subject, consider liking this tutorial, commenting on it and subscribing to our channel and press the bell icon, so that you stay updated and get notified when we upload more videos. Thanks for watching.